today's lesson. So today we're going to be focusing on simplifying exponential expressions. So when we're looking at exponential expressions, we need to first map it out as to what exactly are we going to look at, right? Remember, the concept of exponents includes what we call laws, and it also includes some definitions there, right? And please, I understand that we do English and all. When I talk about definitions, it has nothing to do with something that comes from the Oxford Dictionary or anything like that. It's a mathematical definition. Then in terms of expressions, we are going to look at them in two options. One, when we are multiplying and dividing, and then the other option will be when we are adding and subtracting as well. Now, the key words for this lesson will be mainly the concept of an exponent and also the concept of a prime base, right, or prime basis. Remember that prime numbers will be a number that has two factors, one and itself, right? So our basis, we're going to try by all means to make them prime numbers at all times. That's the main thing that we need to do when it comes to exponents. Now, the concept of an exponent will be the number of times a number, which is the base, is multiplied by itself, right? So in this instance, what this means is if I have a to the exponent of n, this is the same as a being the base and then n being the exponent. Now with this, what I have here, I'm going to be using a term that is power, right? And when I say power, I don't really mean the exponent itself, because I know at times we use the word power to mean exponent. When I say power, I'm talking about the whole thing, a to the exponent of n. The whole term itself is called a power. So when I say multiply one power with another power and the bases are the same, I'm talking about the whole term, not necessarily just the exponent. So please just do bear with me there. And remember, as we're going through this lesson, when I say power, I'm talking about the whole term, not necessarily the exponent. Now, also, with the laws of exponents, as I said, we're going to divide them into their respective operations. One will be when we are multiplying powers of the same base, right? So this is one power, and this will be another power. They have the same base, which is a, and the law will then say that we need to add the exponents. What that means is, please don't then make the misconception of thinking that you need both the bases when you're doing this, right? No matter how many bases you have, if it's a to the m multiplied by a to the n multiplied by a to the b, like this. No matter how many bases you have, as long as they are all the same, you will maintain one and then add all the exponents of all the bases that you have. This will therefore be m plus n plus the b there. And that's the first law that has to do with multiplication. Now, when we are dividing powers of the same base, we therefore need to do the opposite of addition, which is subtraction, because division is like opposite of multiplication. And here I just use a division line, but you know it can also be a to the exponent of m divide by a to the exponent of n. They mean one and the same thing, right? Even with this, it doesn't matter how many powers you have that you are dividing and all. As long as they all have the same base, you then subtract the exponents. Now, one of the other misconceptions that I've realized is when we have maybe a to the exponent of m divide by a to the exponent of negative n, right? And then a person will then say this is the same as a to the exponent of m minus n. This will be a lie. This is not correct. Why is it not correct? It's because you are subtracting the exponent. So it means it needs to therefore be the m minus the negative n, because the n goes with its own negative. So it will be more like you are adding, but in actual fact, you are subtracting a negative term, right, which is that exponent at that time. So please do also pay attention to that. Now, we also have the laws of exponents that have to do with brackets, and there's three of them, right? When we raise one exponent to another exponent, so it's like m raised to that n there. So the law will say we need to multiply those two exponents. And we multiply them again because of the fact that you know that a bracket goes with the operation multiplication, right? So therefore, m multiplied by n will be mn. Just on that mn again, going back to this one, when you are adding these exponents, don't make the mistake of saying the answer for m plus n will be mn. These are unlike terms, so you can't add them. Only when you are multiplying can they then be together. And then the other one will be if I have two terms that are separated by a multiplication inside the brackets, as you can see, a and b, and it is raised to one exponent. You then use the distributive law to distribute that exponent to all the exponents that are inside those brackets, right? And with this one, if we don't have an exponent, you know it's not 0, it's 1, right? Because anything raised to the exponent of 0 will then be something else. It's definitely not what we have here. So this is the same as a to the exponent of m multiplied by b to the exponent of m. And then the last one will be if I have a fraction inside the bracket raised to one exponent, you also use the distributive law to distribute that to the exponent of the numerator and the exponent of the denominator. Now, when it comes to the definitions of exponents, the main definition that you need to know is if I have any number raised to the exponent of 0, it will forever be 1. So I give you a bracket and I give you all numbers there, 10,000 of them, and then I raise this to the exponent of 0. The final answer will just be 1. It doesn't matter what you have inside there. And then also changing the negative exponent to be a positive exponent. Why do we do this? Is because we know that most of the time the answer is always required to be left with a positive exponent. So I hope that makes sense, guys. So remember, the exponent will be how many times a base is multiplied by itself. There's some laws that we use in order to simplify that. It will be the law of multiplication, the law of division. They normally call it the product and the quotient law. And also it will then be the law of brackets that we just did now. From me to you, let's just take a quick ad break, just refresh, take a walk a bit, and then we'll be back so that you can do a bit of questions. Hi guys, welcome back from the ad break. So I hope you guys are a bit refreshed. Now we're going to look at some specifications, right, in terms of simplifying the expressions themselves. That include some exponents there. And then we'll also look at, firstly, when we are multiplying and dividing, what are the few principles that we need to follow. And then later we'll also look at when we are then adding and subtracting as well. What do need to follow from there. But for now, let's look at the concept of multiplication and division of exponential expressions. So remember that an exponential expression may include multiplication and division of terms. So it can be one term multiplied by another term over another term, right? That's what that means. Also, it may include some addition and subtraction of terms. And I know this one is the one that kind of gives you guys a problem at times because you just like cancelling out things, but we will look at it when we get to it. And then with the multiplication and division of exponential expressions, right? When an exponential expression only involves multiplication and division, the very first step that we need to follow there will be to rewrite all the bases to be in terms of prime numbers. Remember when I started, I said we're going to look at prime bases. This is where that comes in. Let's look at an example of what this means. So if I have 6 to the exponent of n minus 1 multiplied by 18 to the exponent of n, you're going to rewrite these terms as prime numbers, right? But only if it's possible to do that. Just from the get-go, change it to exponential form. But if you cannot, then you can write it as a product of two prime numbers. that make that particular number, right? So this is where then the things we learned earlier on when we started doing our mathematics, your ladder method and your tree diagram method of finding prime numbers, this is where it comes in. So we know that 6 is the same as 3 multiplied by 2, and we know that 18 is the same as 9 multiplied by 2, but because 9 is not a prime number, I can convert it to be 3 squared. And all of this will be raised to n. And then from there, remember one of the laws that we looked at under brackets, we distribute that exponent using multiplication there. Therefore, it's going to be 3 to the exponent of n minus 1 times 2 to the exponent of n minus 1 times 3 to the exponent of 2n. Why 2n? Because it's going to be 2 multiplied by that n there. And then lastly, it will be 2 to the exponent of n. Now, remember guys, multiplication in mathematics, right, it's a few things that we use. We use the actual multiplication sign, we use a dot, and we use a bracket. So please make sure that you understand this. You don't want yourself to hear yourself now saying it's 3 to the exponent of n minus 1 comma something, because really that wouldn't make sense. The dot means multiplication in mathematics. Unless we are in a language class, then it will mean a full stop. But here it means multiplication. And then also, when the second step of simplifying this will be to apply the laws and the definitions of exponents, right? I've actually applied one here where it includes the concept of brackets and raising one exponent to the other. Now, with this one, what this means is we left it at this point with the previous example. From here, you can see this is the same base as that base there, and this is the same base as that base there. What does that tell us? Then we can apply either the product rule or the quotient rule, depending on what is the operation between the terms. And the operation here will be a dot, which means multiplication. Therefore, remember the law. If I have a to the exponent of m multiplied by a to the exponent of n, the law is to say I must add my exponents, right? Therefore, I will then group them according to the same basis so that I can then add my exponents accordingly. So the 3 will go with the 3 there, which will make it n minus 1 plus 2n. Then multiplied by the 2 here will go with that 2 there, and then it will be n minus 1 plus n. Then you know that n plus 2n will give me 3n, and then minus 1 does not have a like term, so I will leave it as is. And then n plus n will give me the 2n there. Then minus 1 remains as is because it doesn't have a like term, right? So the two main steps here is, 1, convert the terms, your bases rather, to be prime numbers. 2, apply the laws of exponents. From there, let's just look at, in practicality now, what exactly does this mean? The statement you're going to get for such questions will be simplify the following questions. And they will at times add to say leave your answers as positive exponents, right? But that's one of the requirements at all times. When you're having a division and all, they always tell you that leave your answers in positive exponents, because mathematically, we hardly leave our answers as negative exponents. Right, so the first question will therefore be 4 to the exponent of x multiplied by 2 to the exponent of x minus 2, all divided by 8 to the exponent of x minus 1. Now, I know you guys, and I know how you think, right? The very first thing that you will then think when you are in a situation like this will be to multiply the 4 and the 2 to get an 8. But you cannot do that. Why? Because we're dealing with exponents. The exponents normally take dominance over what we are doing. So where do we go? We go to the concept of prime basis. That's the main thing that we need to then look at here. So you know 4 can be written as 2 squared, which will therefore give me 2 squared, I will open brackets there, x multiplied by 2 to the exponent of x minus 2 divided by 8 can also be written as 2 cubed to the exponent of x minus 1. And then you apply your laws of exponents here. This will give me 2 to the exponent of 2x multiplied by 2 to the exponent of x minus 2, all divided by 2 to the exponent of 3x minus 3. Then, because we have both multiplication and division, we'll start with multiplication and then apply the division after, so that I don't confuse you guys. So, at the top, I'll start with multiplication. That will be 2 to the exponent of 2x plus x minus 2 over, I'll rewrite my denominator as is, which is 3x minus 3. And this will give me 2 to the exponent of 3x minus 2. And then I apply the quotient rule here, right? Which will therefore minus. I put this in brackets because I am subtracting more than one term. And therefore the final answer will therefore be the 3x and the 3x will cancel out because it's going to give me 0. Then minus 2 plus 3 will therefore give me 1, which is the same as just 2. Remember, we don't necessarily write 1. Now the second example will therefore be 3 to the exponent of x plus 3 times 18 to the exponent of x divided by 6 to the exponent of x plus 1 times 9 to the exponent of x plus 1. Same thing applies. You don't then start multiplying your bases or anything like that. Instead, you go to your prime bases. So this will be 3 to the exponent of x plus 3 multiplied by, so this I'm just going to write it as 3 to the exponent of 2x multiplied by 2 to the exponent of x, right? Where does that come from? It comes from me having 3 squared multiplied by 2 all raised to the exponent of x, right? Because it's 9 times 2, which is the 18. Divided by, here it will be 3 to the exponent of x plus 1 times 2 to the exponent of x plus 1 times 3 to the exponent of 2x plus 2, right? Because I'm going to distribute my 2 there. 9 is the same as 3 squared. Then from here, I will apply the laws all at the same time now, because with the previous one I showed you how you can do it so that you understand it. So this will be 3 to the exponent of x plus 3, then plus the 2x, right? That's what is at the top. What is at the bottom, I must subtract it, which is minus the x plus 1, and then minus again the 2x plus 2, right? And then multiply this by 2. I only have 2 of them, so it will be 2 to the exponent of x minus x plus 1, right? And then you can then work out your exponents there. This will be 3, this x, the 2x, and that x there will give me just 2x, so I will have 2x there. This 3 and that minus 1 will give me plus 2 multiplied by, then the 2 will be to the exponent of 1, which I am really not going to write. And this will be my final answer there. Please remember, you don't need to then multiply the 3 and the 2 to get a 6. But this will therefore be the final answer for this particular question. So as you can see with this question that we just did now, right? The main thing that you need to follow there, one is to make sure that your bases are the same, right? When I say bases are the same, some numbers you cannot really convert them straight away to a certain exponential form, but you will need to write them as a product of two numbers, right? As you saw with the previous example, just to show you what I'm talking about, right? The 4 can be converted, the 8 can be converted, but with this one that we just did now, I cannot convert 18 to anything that is in exponential form unless it's a product of two terms. Similarly with the 6, similarly with the 9, I can definitely do that because it then becomes 3 squared, right? So that's the main thing. So with everything that we've done, make sure, number one, that you have your prime basis, which I will just say it's PB, and after doing that, then apply the concept of your laws of exponents, right? Either the laws and also the definitions. Why am I saying the definitions? Because at times you will find that the answer that I'm left with here as the exponent of maybe this 2 is 0, right? I will not leave this as 2 to the exponent of 0. The next equal sign will therefore be to substitute this 2 to the exponent of 0 as 1, because that's what the definition says. But for this one, that's not what it says. So I'm just going to erase it so that it does not confuse you. But that's really the main thing that you need to make sure that you understand. Prime basis, apply your laws, your definitions, and then from there, make sure if you do not understand how to do this, just start with the top and work out everything that's at the top. Go to the bottom, work out everything that's at the bottom, and then combine them after that. And then you will get your answer from there. Hi guys, welcome back. So right now we're going to look at then the concept of the addition and subtraction of exponential expressions. So remember our mind map, we've been looking at the concept of exponents together with its laws and the definitions. And then when it comes to expressions, we've then dealt with the multiplication and division. Now we're going to mainly focus on the addition and the subtraction, right? So when an exponential expression includes addition and subtraction, the main thing that we use here is called factorization, right? I know you guys run away from this because at times it becomes a problem, but now we're going to do it with exponents. Now, the first one, or the first very common method, is the common factor type of factorization, and then any other type of factorization depending on the expression that you have at that time. Now, the important principles to note will therefore be, remember, a to the exponent of m plus n is the same as when you were multiplying powers of the same base, which is a to the exponent of m times a to the exponent of n. So it's like you are reversing it, right? Because remember, when it comes to the law, I give it to you like this, as a to the exponent of m times a to the exponent of n. Then you need to come this side. But with this one, it's like you are reversing it. So I'm going to give you something with exponents added. Then you will need to use the word, this thing called splitting them, but using this principle. The other one is a to the exponent of 2x is the same as a to the exponent of x, all raised to 2. Remember the law of brackets that we spoke about, which has to do with multiplying those exponents. So simplifying using factorization, the common factor type will be, we normally factorize, or we often factorize this using taking out a common factor, right? When you're taking out a common factor, it is when we see something that is common in those terms that we are dealing with, right? It might be 3 terms, it might be 4 terms, as long as there is one thing that's common throughout. Not common just on the first 2 terms and then the last 2 terms do not have anything. And then you act as though you're taking out a common factor for everything. Now an example of this will me having 2 to the exponent of x plus 2 minus 2 to the exponent of x minus 1, right? So remember the principle that I just showed you now. This can be split into 2 powers of the same base. This can also be split into 2 powers of the same base. And that will therefore give you 2 to the exponent of x multiplied by 2 to the exponent of 2 minus 2 to the exponent of x multiplied by 2 to the exponent of minus 1. And you then take out a common factor, which is the 2 to the exponent of x on both terms. Now, with the concept of a common factor, guys, remember with a common factor, when you take it out, right, you take each term from the expression and you then divide that by the common factor that you took out. That's the concept of a common factor. You don't just scratch out and then, because if it's just the common factor itself, some people then don't write 1 that's remaining. They then write 0 because they're thinking they cancel out. No, you definitely need to take each term and divide it by the common factor in order to get what is remaining after that. So what I will be left with, if I divide the first term by the common factor, will be 2 to the exponent of 2, and then the second term will be 2 to the exponent of -1. Now, factorizing using what we call the difference of two squares, if I have 3 to the exponent of 2x minus 9, this is the same as 3 to the exponent of x all squared minus 9. So remember that this is a difference of two squares. It's the same as me having x squared minus 9, right? Then I can then factorize that using the difference of two squares, right? This is just an approximation just to show you what it means. Now, we then also have what we call the quadratic trinomial. Now, this is the special kind of factorization when it comes to the concept of exponents. Here, guys, the main thing that you need to make sure that you understand is your first term, the exponent for the first term must be such that it is always twice the exponent of the middle term, right? So, I will repeat. The exponent of your first term must always be twice the exponent of your middle term. Then that's a quadratic equation. Why am I saying this? Remember, just from algebra, x squared plus x minus 2 maybe, right? The first one is x squared. The exponent is 2. The middle term is just x. The exponent is 1. Therefore, 2 is twice 1. That's what I really mean here. Always make sure you don't use opening binomials here when that's not the case, right? If I give you maybe 1 over 2 and then I give you 1 over 4, then you look at what exactly is it that is happening there. Is this twice that? If not, then employ another method and not necessarily the factorization method. So please do note that. But let me show you how you will then factorize this, provided that it is a quadratic trinomial. So you can see this is 2x and that is x. So it shows us that it is twice that, right? So this will be the same as applying the principle that I said was important for you to note. 2 to the exponent of x, all raised to 2. And then you can then see that the first term here is 2 to the exponent of x. So the exponent is the same as that one. But because of this 2 that is outside, it then makes the main principle that I was saying now, it being twice the exponent of the middle term. And then if you factorize this, it therefore becomes the same as 2 to the exponent of x minus 4 into 2 to the exponent of x plus 1. Now, another way just for you to understand this better, right, is you can always just say let 2 to the exponent of x be k. You see, then immediately you know that you now have k squared minus 3k minus 4. This will be easier for you to factorize as opposed to when it's there in this particular form, right? So that's one of the ways you can employ here. But always remember that you let k to be something else. So you don't leave it as k at the end. You always substitute what k was initially, right? So that's one of the ways you can do this. So simplifying addition and subtraction, one common factor, or factorization. Remember, guys, factorization is not only about opening two brackets. At times, you can take out a common factor. That's also one type of factorization. But I know that I've said a lot, and I'm sure that you guys have also taken down some notes that are important there. But for now, let's just refresh a bit and take a quick break, and I'll be back with some questions for us to practice what we just spoke about. Hi guys, welcome back. So I hope that you are now refreshed and you are ready to try some questions with me, right? Now remember, the most important thing here that we've been looking at, guys, is make sure that you understand what is what is separating your terms? Is it multiplication, division, addition, or subtraction, right? That will inform what method you need to follow. But so far, we're looking at the addition and the subtraction, and we said the method that we employ there will be the concept of factorization, either common factor or any other type of factorization. But let's now put this into practicality and see exactly what is it that I mean when I say take out a common factor. Because somebody might be thinking, what exactly do I do there? But let's try these examples together. Please also try them. As I'm doing them, just also jot down something so that you understand what I'm busy doing here. Now, the question, remember, at all times, because it's expressions, it will always be simplify the following, right? That's the main statement that you will be given. To simplify the first question, which is 3 to the exponent of x plus 1 minus 3 to the exponent of x plus 2 divided by 3 to the exponent of x minus 3 to the exponent of x minus 1, right? So this is the one that now the concept of taking out a common factor, right, comes into play, and using it appropriately and properly so, right, because you will see what I'm talking about when I say using it properly so. And then before you get to the common factor, you will then need to do what we call split this thing, right? To split it is to use the principle that we spoke about, where you are reversing the product law that we were talking about. So the very first thing that I'm going to do here is to split this, which is 3 to the exponent of x times 3 to the exponent of 1. I don't really need to write the 1, minus 3 to the exponent of x multiplied by 3 to the exponent of 2. I did not change anything here. I just rewrote this as what it was before it got to be 3 to the exponent of x plus 1 and 3 to the exponent of x plus 2. Divide all of this by 3 to the exponent of x. I don't need to do anything there. Minus 3 to the exponent of x times 3 to the exponent of negative 1. So I know I said I don't need to write 1, but now this is a different one. It's a negative 1. So you definitely need to write it down, right? So we've done this. After we split, we then go to take out a common factor, if there is a common factor. So here you can see that the 3 to the exponent of x and the 3 to the exponent of x is there. And the 3 to the exponent of x and the 3 to the exponent of x is there. Now, guys, you know what? I know that you like easy things, right? And shortcuts. You don't cancel out anything here. Why do you not cancel? Because there is a minus and a plus between these terms. So you don't play around with cancelling. Right? Although you can see if I cancel the first two, I cancel the other two, then the answer will kind of work, but you do not do that, please. So don't just rush to then cancelling. You can only cancel if the terms are separated by a multiplication or a division in between them. That's only when you can then cancel. So do not then cancel my 3 to the x's here and think that's what you then need to do. So I'm going to take out a common factor here as I've highlighted them. So this will be 3 to the exponent of x as a common factor. You open the bracket to show what is remaining, right? If I take the first term divided by the common factor, I will remain with 3 minus, I take the second term, I divide it by the common factor, I will be left with 3 squared. And all of this will be divided by 3 to the exponent of x. You open the bracket. Now this is where that concept of using the common factor appropriately comes in, right? So some people will think because I have 3 to the exponent of x as the first term and I'm taking out a common factor of 3 to the exponent of x, they therefore think the remaining answer will then be 0. That's not the case. Remember I said when we use the common factor, we use it in the form of dividing and not necessarily just cancelling out, right? So it means if I divide 3 to the x by 3 to the x, the answer will be 1. If you want to apply the laws of exponents, it will be 3 to the exponent of 0, which goes back to being 1. So it's really an either-or situation. So this will be 1 there, minus, then here I will be left with 3 to the negative 1. Then, only then can you then cancel out the things that look alike, right? So you can see what is outside the bracket, this, and that will therefore cancel out, and then I will be left with only what is inside the bracket, which will therefore be 3 minus 9 all over 1 minus 1 over 3, right? Now, when you get here, you can always just press your calculator. It's really not a problem to get your answer, right? So this will be negative 6. At the bottom here, I will just work it out here because I'm not going to use the calculator. This will be the same as 3 minus 1. It's going to be 2 over 3, right? That's what I'm going to have there. So it means I am multiplying this by 3 over 2, right? And then if you want the answer here, it will then be negative 18 over 2, which is equals to 9, right? So you can always just use your calculator here, a negative 9, by the way, not a positive 1. But when you get to that point, you can just press your calculator and find what the answer is. Now, one last question for us to look at is 3 to the exponent of 2x plus 3 to the exponent of x all over 3 to the exponent of x plus 1. Now, when the situation is like this, you already see that at the top there is a common factor that I can get there, right? But at the bottom, hardly, because 1 can never be 3 to the exponent of x. So I will work out what is my numerator with the hope that it will look like my denominator. Then I will cancel out things that look alike if they are. But if they are not, then we'll always reverse and see what we need to do. So this will be 3 to the exponent of x times 3 to the exponent of x, remember that, plus 3 to the exponent of x, all divided by 3 to the exponent of x plus 1, right? Now, let me just highlight where this comes from. This is the same as me having 3 to the exponent of x plus x. Remember, that's how we get 2x, right? So that's where that particular thing comes from. This will then be, I take out a common factor of 3 to the x, I will be left with 3 to the exponent of x plus 1, and then divided by 3 to the exponent of x plus 1. Voila. Now you can see some light at the end of the tunnel. But the light is not to then cancel out this and that, because I know that's what you guys are kind of used to, because if you cancel once, you think all the time you will need to cancel, right? So 3 to the exponent of x, you can see what is inside the bracket and what is at the top is what is the same, and that's what you cancel, not the 3 to the exponent of x. Then your final answer will just be 3 to the exponent of x. Now, let's just talk about a few rules that I've mentioned here that I want you to jot down for me. Remember, you do not cancel out anything unless there is a multiplication or a division between those two terms that you are trying to cancel with another one, right? When there is a plus and a minus, you make sure that you factorize, right? You factorize by doing what? Either taking out a common factor or using the factorization of a quadratic equation, but in the form of an exponential form. And if that is a bit difficult for you, just try to then simplify it and let the common thing to be a letter K or a letter V, a letter S. It doesn't really matter what letter you are using, as long as at the end you're going to substitute it back into what it was originally before you then introduced something new. But when you introduce something new, you don't just introduce it. You tell me that let to be equal to K. You don't just then substitute K, because then I'm going to wonder where does K come from, right? So that I know that this is the flow. Remember, maths is a language, guys. You are communicating with me to say, I'm doing this, now I'm doing this, now I'm doing this. So always make sure that those little nitty-gritties, you do follow them appropriately. Now, let's look at the concept of the difference of two squares, right? Why is this a difference of two squares? At the top, it can be the same as 2 to the exponent of 2x minus 1 all over 2 to the exponent of x plus 1. I don't need to do anything at the bottom because really there is nothing I can do. It's more like the previous example we just did. But at the top, you can see that this part here is the same as 2 to the exponent of x all squared, right? Which means it is the same as me having x squared minus 1 if you then wanted to just simplify it for yourself. I'm not saying this is what you write as your answer, no. Just so that you can have an idea while you are practicing what exactly this is, right? If I wanted to factorize this, it will be x minus 1 and then x plus 1, right? But what is our x here? It's 2 to the x. What is the other x? It's 2 to the x, right? So you can see this will be 2 to the exponent of x minus 1 into 2 to the exponent of x plus 1, and then all divided by 2 to the exponent of x plus 1. And then you can see there is things that look alike there, which is this and that bracket. Therefore, my final answer will just be 2 to the exponent of x minus 1, like that. You don't subtract anything there. The 2 and the 1 are not like terms because there's an exponent. You just leave it as is. Now, the interesting one will therefore be this one, where now we are dealing with the concept of a quadratic trinomial, right? So this will be the same as, I'm just going to simplify it for you quickly before we can simplify it, squared, and then plus 5 to the exponent of x times 5, right? And then minus the 6 there, all divided by 5 to the exponent of x plus 6, right? So you can see that, remember, I said, if you don't understand this, then introduce something that you can work with. So you can always just say, let the 5 to the exponent of x be what? K. And then you can then work it out. So this is the same as k squared plus 5k minus 6, right? If I factorize this, this will give me k plus 6 into k minus 1, you see. So you can already see that this is definitely factorizable. But because our k was the 5 to the x, I'm just going to write it as is. I was just trying to show you how you can then simplify it for yourself. So this will be 5 to the exponent of x plus the 6 into 5 to the exponent of x minus 1, all divided by 5 to the exponent of x plus the 6. Remember again, this and that look alike, then the answer will finally be 5 to the exponent of x minus 1. Now, when it comes to this one, difference of two squares in a quadratic trinomial, if it doesn't make sense, just make sure that the one with the variable as the exponent, you introduce it as another variable that you want. I use k because normally we use k in mathematics, right? But you can use any other variable that you want, as long as at the end you will substitute back to say k was this, not to leave it as k, because we don't have k here. I have numbers and x. As soon as you leave your answer as k, it means then you have changed my question, which will then be a problem, and I will not be able to award you marks if it was a test or an exam situation. Now, one last one, just to simplify this one, right? This will be 2 to the exponent of 2x, right? Plus 2 to the exponent of x times 2 plus 3. Now you are familiar with what we need to do here, so I'm just going to do this one straight away, right? Which will therefore be equals to 2 to the exponent of x in the bracket, and then another 2 to the exponent of x. The 3, you can find it by multiplying the 3 and 1. Oh, it's 2 squared here, sorry. So it's 3 and 1 plus, and then over 2 to the exponent of x plus 3. Then these two cancel. Then finally, it's 2 to the x plus 1, right? So I hope that is clear. Now, a summary of what we've looked at so far, please go back and look at your laws of exponents because they are very important in this concept, and then also practice your simplifying of expressions, which is in two ways, and those two ways is when you are dealing with multiplication and division, and also when you are dealing with addition and subtraction. Guys, that's from me, the Maths Doctor. I hope you enjoyed this lesson as much as I did, because really I know exponents are a bit of a problem, but if you were following me, I hope that you did understand everything that we've done. From me to you, remember, mathematics is food for the soul. Until next time.